Good morning. In this lesson, we are going to discuss about CAMs. Objectives of this lesson. On completion of this lesson, you would be able to know about the CAMs, applications of CAMs, types of CAMs, and types of followers. So friends, as you are engineering students, you should know, do you know about this? How valves are operated in four-stroke petrol engine and working of a printing press. Working of a printing press. I think most of are aware that in four-stroke petrol engines there are some valves which are opening as per the requirements. So during how they will be during its operation, engine operation, how the valves will be opened and closed. If you are aware of the opening and closing of the valves of IC engines, then you are also aware of the cams. And similarly, the working of printing press also, if anybody knows, in such case also how the printing is going to take place. In such case also they will know the idea of or they will have the knowledge of cams. So let us see one as the example for a cam. See here in this, if you observe this red plate or whatever it is, this may be the cam, and it is rotating about a point. As it is rotating, one of the vertical rod, let us take vertical rod, in between these two supports is reciprocating vertically. Due to reciprocation of this vertical rod, a man supporting at the top end of this vertical rod is going to have a oscillating motion. So that means the cam is rotating and the vertical rod is reciprocating vertically due to the rotation of the cam, and the hand of the person is oscillating. So this is the operation of the principle of cam mechanism. So let us see here also the same thing. Here the same thing is happening. So this is the best example for a cam. And now let us have what is mean by cam. What is the definition for cam? Cam is a rotating element. As we have seen in the previous cam example, the disc in shape of a oval is rotating about its axis. So that's why the cam is a rotating element. And this rotating element imparts a reciprocating motion or oscillating motion, as in the previous case, to the vertical rod. Due to the motion of the vertical rod, the hand is oscillating in the previous case. Similarly, here also, the one is the reciprocating element and one another is the follower element. So here you can see the vertical rod is vertically reciprocating, the hand is oscillating, whereas the disk is rotating about its own axis. So the cam is a reciprocating element which imparts a cam is a rotating element which imparts reciprocating motion or oscillating motion to the follower. Here the follower is the vertical rod and the rotating element is the disk. That means due to the rotation of the disk, the vertical rod or the follower is reciprocating vertically. So that is the cam. And found in modern machinery, just like you can see IC engines, opening and closing of walls, and similarly printing press, and also in automatic machines, semi-automatic machines. In such cases, we are going to use the cam mechanism. Here you can see so here is the cam, this is the cam which is rotating about its own axis, and at certain point the height is more and at another point the height will be less. Due to this difference, this is the roller follower, this is the roller follower, you can say. This follower is reciprocating vertically within the supporting frame. This is called frame and this is the follower, this is the cam. So it is the best example, it is the cam mechanism. So a cam is a rotating machine element. This is imparting the reciprocating motion to this follower. This is roller follower. So, and as you observe this mechanism, this roller is always remaining in touch with the cam, right? So this is the cam mechanism. The contact between cam and follower. Here you can see this is the shaft, and as it is rotating, this cam is also rotating, and this follower, knife edge follower, here you can see this is always remaining in contact with the, and this is rotating element, this is called cam, and this is the follower, knife edge follower, we can call it as, and it is having reciprocating motion. That means this is remaining in contact with the cam profile, cam outer part. Only here in this case, due to the gravitational force, the cam and the follower have a line contact. Because they are in contact with each other always, and they are having a line contact only, and constitute a higher pair. The pair which is having line contact is called higher pair, which is have line or point contact. The pair, the two elements which are having either point contact or line contact is called higher pair. And if the two elements are having surface contact, then it is called lower pair. So here the cam and its follower are having line contact, that is why it is constitute a higher pair. In the previous example, as you observed, the rotary cam, rotating disc cam, as well as the knife edge follower are in contact with each other only because of gravitational force. Now here the rocker arm, this is the rocker arm and this is a spring and this is the cam. As it is rotating about this axis, and this roller follower of the rocker arm is in contact with the line contact with the rotating disc follow cam, and it is giving, actually at this point it is having oscillating motion. Due to this oscillating motion above, which is pivoted at this point, this arm is having once again oscillating motion, and this follower is always remaining in contact with the cam due to the spring force, due to this spring force. This is the, that means the follower always remains in contact with the surface of the cam, either by either by gravitational force or by spring force. Here you can see it is just like similar to the ice engine valve opening and closing. So here you can see this is the camshafts, and these are the cams. Disc cams are also called plate cams, and this is the follower which are having, and both are having reciprocating motion. As you observe, one is opening and one is closing, one is opening and one is closing. Only because of the shape of the, this is happening only because of the shape of the cam. And this is the best, is the example of ice engines, right? So, and here you can see another example of cam and follower. Here you can see, and this is the wall of ice engines, and this is the cam mechanism, and this is the camshaft. And due to opening and closing of this is the reciprocating motion, oscillating motion of this rocker arm, as it is remaining in contact with the cam, and this is rocker arm is always oscillating in this direction, and which other end is other end of the rocker arm is connected to the wall. Due to oscillation of this one, this will have, and other edge also are having oscillating motion. Due to oscillating motion, this is connected to this wall, thereby it is having reciprocating motion. So it is the best example of cam and follower in ice engines, you can see. Here you can see the actual, this is looking like an actual ice engine parts. Here you can see, this is the crankshaft, this is the piston rings, cylinder, and also connecting rod, crank pin, and crank. And this is the camshaft, and this camshaft is driven by the crankshaft. And on the camshaft, the two cams are provided, which are used to have reciprocating motion to the valves. So that means the valves are always operated by cam mechanism. Whenever we need opening of one valve will pause, and another is closing, and another is closing, and another valve is open. So this is another best example of cam and follower mechanism, which is the best example as we are seeing in automobile industry ice engines. So here you can see another example is, this may be the example of press. So it is the flat follower. Here you can see this is the flat shape. It is the flat shape, and this is also going to reciprocate vertically up and down, and this is rotating about its shaft. So here you can see the follower here in this case is roller follower, and here it is the knife edge follower and plate cam or disc cam, and here is the roller follower, And here are the flat followers, and here is the mushroom follower or flat follower, and here are the flat followers, and here is also a flat follower. Here you can see once again the same example, IC engines, it is opening, and here are also flat followers. As we are seeing, it is having reciprocating motion, it is having rotary motion. This will be the follower, this is the cam, disc cam, plate cam, and this is the camshaft. And here also another example, just like it is also in just like example of IC engines. So this is the wall which is opening, and this is a cam shaft and cam, and this is the rock arm, and this is always a follower which is in support in connection with the plate cam. So here you can see the Wankel engine. Here you can see the same mechanism as we are using. Wankel engine also we are using the same mechanism, cam and cam shafts. The cams are usually rotated at a uniform speed by shafts. That means these cams are rotating at a uniform speed due to rotation of the shafts, and follower motion is predetermined and will be according to the shape of the cam. That means the follower motion will be depending on the shape of the cam only. That means if the shape is different, the motion may be different. The shape is round and it is different. So the follower motion mainly depends on the shape of the cam, and also which is predetermined only. So that is the working principle, simply the working principle. As if you see the working principle of this cam mechanism, the cam is rotating about its own axis, and the follower is going to move have either oscillating or reciprocating motion due to the shape of the cam, according to the shape of the cam. And this cam always moves at a uniform speed about its shaft axis, and the follower will be reciprocated within the frame of the supporting frame of the follower. This is the working principle of cam mechanism. So let us have the applications of cam mechanism. The cams are widely used. Cams are widely used in IC engines, as we have seen, for operating the inlet and exhaust valves, automatic attachment of machines, and paper cutting machines, spinning and weaving textile machinery, feed mechanism of automatic lathes, show making machines, printing machines, clocks, automatic screw cutting machines. So these are some of the applications: IC engines, automatic attachments of machines, paper cutting machines, spinning and weaving textile machinery, feed mechanism of automatic lathe, shoe making machines, printing machines, clocks, automatic screw cutting machines are some of the examples which are going to use this cam mechanism. Now the classification of cams. So there are mainly two types of cams are there. One is the radial cam, also called disc cams, and cylindrical cams. And third one is also wedge cams. There are mainly three types of cams. One is the radial or disc cams, cylindrical cams, and wedge cams. Radial or disc cams, the follower reciprocates or oscillates in a direction perpendicular to the cam axis. The follower reciprocates or oscillates in a direction perpendicular to the cam axis, and cams are of reciprocating type. That means radial cams are reciprocating type, tangent or circular type. So the radial cams, here you can see this is the guide or the frame, and this is the follower, and this is the cam, and this will be the working surface of the cam, and this is the axis of the cam, and this is the axis of the follower, and this is the another follower, and this is axis of the follower and center of cam, and here it is the offset which is away from the axis of the cam and cam shot. And next is cylindrical cams. As the cams are rotating about its own axis, cylindrical cams which are having a groove which is required, which is cut as per the requirement of the motion of the follower. So as it is rotating about its own axis, the follower is in touch with the cam within the groove, and which will define the motion of the follower. The follower reciprocates or oscillates in a direction parallel to the axis. That means the follower here in this, if you see in this figure, as it is rotating about its own axis due to the shape of the cam groove, this is going to have a reciprocating motion parallel to the axis. If you see this one, and it is the follower, and as per the rotation of this cam, this cylindrical cam, this will have an oscillating motion to the follower. These are the two types. One is, generally three types are there which will provide either reciprocating or oscillating motions. Number one is radial or disc cams, cylindrical cams, and wedge cams. In case of radial or disc cams, we are having tangential cam and circular cam. And now the types of followers. Types of followers based on the surface in contact. Based on the surface in contact, knife edge follower, roller follower, flat faced or mushroom follower. Knife edge, roller, and flat faced or mushroom follower, and spherical faced follower also there. Based on the motion of the follower, it is based on the surface in contact. Surface in contact means knife edge follower, roller follower, flat faced or mushroom follower, spherical faced follower, and based on the motion of the follower, it is reciprocating or translating follower, oscillating or rotating follower. Based on the path of motion of the follower, here are the two types: radial follower or offset follower. If the axis of the follower passing through the center of the cam or axis of the cam, then it is called a radial follower. If the axis of the follower is passing through the away from the axis of the cam, then it is called offset follower. Here you can see this is a wedge cam. As it is, this cam is reciprocating horizontally, which due to the height difference, wedge shaped difference, and the follower is going to have vertical reciprocating motion, and the bottom of the follower is in the shape of knife, a surface in contact with the cam. That's why it is called a knife edged follower. And if you see this is a plate cam, and the roller follower is there, and this is called a roller follower, as it is the shape of roller. That's why it is called roller follower. And next is flat follower. If you see the bottom surface of the follower is in the shape of flat surface, that's why it is called flat follower. And the bottom of the follower is in the shape of, the surface is in the shape of spherical shape, that's why it is spherical follower. If you see in the roller follower example, the axis of the cam is passing away from the axis of the cam. That's why it is having some eccentricity. That's why it is called offset. So that's why it is the offset follower. As the axis of this follower is passing through the center of the cam, or the axis of the cam, and this is called radial follower. Oscillating follower. Here you can see, as it is rotating, the cam is rotating, the follower is pivoted at this point and fixed, and this follower is going to oscillate in this direction, in this way. That's why parallel to the axis of vertical axis of the follower, this is oscillating follower. And it is, see, if you see offset follower, and the axis of the cam is different and axis of the follower is different, which are having certain amount of offsets. That's why it is called offset follower. So this is all about the types of cams and the working principle of cam, and the types of cams, types of followers, etc. So far we have discussed in this lesson. So once again, if you recall all the so far whatever we had discussed, so summary of this lesson, we have discussed about the cams, what is mean by cam, what is the working principle of cam mechanism, and what are the various parts of cam. The cam mechanism will have camshaft, cam, follower, and the supporting frame, you can see, right? So these are the elements of cam mechanism. And then what are the applications of the cam, also we have so far discussed in this lesson. And then, and types of cams, generally the types of cams are, number one is the radial or disc cam, also called plate cam. Number two is cylindrical cams. In cylindrical cams, which will provide you both oscillating and reciprocating motion. In radial cams also we are going to have radial oscillating and reciprocating motion to the follower, and wedge cam is also going to give us both the types of motions, that is reciprocating as well as oscillating motion. So in this cams, applications of cams, types of cams, types of followers also we have completed in this lesson. Let us have some small quiz on this lesson. A cam and follower constitute higher pair, lower pair, screw pair, none of the above. So as we are having discussion during the CAM mechanism working principle, the two elements which are having either point or line contact, then they constitute a higher pair. If the two elements which are having surface contact, then it will constitute a lower pair. And the screw pair is nothing but the bolt and screw. Both are the elements which are having screwing. That's why that is screw pair. So here in the cam and follower mechanism, they will have either the point contact, either the follower and the cam will have either point contact. In case of disc cams, it may have line contact also. So that's why the cam and follower mechanism will have line contact. That's why it is higher pair. So right, so the answer is higher pair. Okay, next, the type of contact between a cam and follower is, the type of contact between a cam and follower is point contact, line contact, A and B, and none. The type of contact between a cam and follower is number 1 point contact, number 2 line contact, number 3 that means C point as well as line contact, and none of the above. So which is the right answer among this? So let us see both A and B, because in case of flat follower sometimes it will have point contact, and in case of knife edge follower also it may have point contact, so sometimes it may have line contact also. That's why the cam and follower have both point as well as line contact. C is the right answer. So thank you friends for patient hearing. So this is all about the introduction to CAM mechanism, what is CAM and what are the elements of CAM mechanism, and the applications of CAM mechanism. Examples also we have discussed in this lesson, and also we have discussed so far the types of CAMs, types of followers. So far we have discussed, and also a small quiz. Thank you.